Alright, so in this video, we're going to look at factorizing quadratic expressions. So a quadratic expression is of the form ax squared plus bx plus c. So, so all these numbers are real numbers. A is a real number, B is a real number, C is a real number. The only condition really is that A can't be 0. So think of it this way. So we have our unknown x, or unknown in x, so this is x squared. And think of it, if A is 0, then you will be left with bx plus c, which is a linear type of expression, because the highest power here would just be 1. While if A is not 0, then you'll always have the unknown to the second power. So in this case, x to the second power. Right, so let's start off with an example. So we can try x squared plus 3x plus 2. So, this is another example of a quadratic expression. This time, our a would be 1, b in this case would be 3, and the c here is just 2. So the thing about factorizing a quadratic expression is that we have to look at what we have for a in this case, 1, and what we have for c. So the method that we'll be using is sometimes referred to as the AC method. Why? Because you take the coefficient, the x squared coefficient in this case is a, and you take what c is, in this case is 2, right? And you look at what the product of those two numbers are, in this case is 2. Then you ask yourself, what factors of 2 such that when you add or subtract them, you get the middle term, in this case b, and b here is 3, right? So when you look at 2 factors of 2, you can quickly pick out 1 and 2. And you can also say that 1 plus 2 gives you 3. So again, it's factors of AC. AC in this case is 2, such that when you add or subtract them, you get the middle term, B, and B in this case is 3. Right? So we say that 1 plus 2 would work. So we go here and we rewrite the middle term as x, right, plus 2x. So in this case, 1x is the same as x. So we write x plus 2x plus 2. So all we did here was to rewrite the middle term as x plus 2x based on the information we would have derived from here. Now, as you would have recalled in the video on factoring by grouping, we would just look at the first pair, factor the first pair, we get x into x plus 1. Then the second pair we factorize by putting a 2 outside the bracket, and then x plus 1. So right here, we see that we have x plus 1 and x plus 1 is common. So we can, again, write that outside this bracket, and this bracket now would contain x plus 2. And at this point, we are through with the question. So here's another question. So again, our A is 1, or C is minus 6. So A times C is minus 6, right? So we're going to look for factors of minus 6 such that when we add or we subtract them, we get 1, right? So we notice that our B in this case would be 1, because we have 1y, right? So let's look at some factors of minus 6. So if we were to go through, and say, okay, let us try, we know that 1 can go in, we know that 2 can go, and we list all of them. And the condition is that whatever factors that you choose, they must multiply and we get back -6. So in this case, if we're choosing 1 here, then it would be, let us choose them by pairs first. So if we're choosing 1, then this would definitely have to be a -6. So let us cross this out and put 1 and -6. Why are we doing it this way? We want to have a situation where when we multiply these two factors, we get back AC. All right, so this could even be -1 and 6. However, look, when we add these two, we obviously can't get a 1 here. So if we should think about it, something like 3 and -2. So these are factors, and when you put them together, you get a 1. So this certainly works. So let us try that instead. So we have 3. So let us write the y squared first, then 3y minus 2y minus 6. And then we factor the first pair, so y into y plus 3. And then factor the second pair with a -2 on the outside. So y plus 3. And then we say that y plus 3 is common. So y plus 3. And then y minus 2. And that would wrap up that question. Now, for a more interesting question where a is some number other than 1. So far in the last two examples, we had a being 1. So in this case, a is 3 and c is 2. So a times c is 6. So we're looking for factors of 6 such that when we add them or subtract them, we get a -7. So I can run quickly to the solution, right? So in the interest of time. So we can see where -1 and -6, when we multiply them, of course we get a +6. And also when we, put them together like so, we get -7. So we can rewrite this -7 now, right? So when we rewrite the expression, we write -7 as minus, so we're going to use a -1, so rewrite -7x to be exact, as -x minus 6x plus 2, right? So we write -7x as -x minus 6x. Then we factor by pair again. So we get x into 3x minus 1. And then this looks like a 2 into 3x minus 1. And then, of course, these are common, so we can write 3x minus 1 into x minus 2. And that would be that for that question, really. So we can continue with some more examples in another video.